Whoops. All right, trig functions. So let's say we have the point 6, -8. This is an easy one. 6, -8. Sorry. Boom, boom. How about that? That's better. Okay, we're at 6, -8. What quadrant are we in? 4. Very good. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Boom, boom. Looks like that. Now, do I draw over the y-axis or up to the x-axis? Up the x-axis. My angle is right next to the origin. So that's the angle I'm talking about. This side is 6. This side is -8. How do I find my hypotenuse of that triangle that I just drew? Pythagorean theorem. 6 squared plus -8 squared equals c squared. So 36 plus 64 equals c squared. C squared equals 100. So c equals 10. So it's a nice one here. Okay? So what is the sine of theta? Well, sine of theta is the opposite over the hypotenuse, which is -8/10, which reduces down to -4/5. What's the cosine of theta? 6/10, which reduces down to 3/5. What's the tangent of theta? -8/6, which is -4/3. What is the cosecant of theta? 10/8, which is -5/4. What is the secant of theta? 10/6, which is 5/3. And what is the cotangent of theta? 6/8, which is -3/4. Okay, we can do that, right? Okay, that's just a review. Now, if we have a 30-degree angle and we make a triangle, okay? It's a 30, 60, 90 triangle. What do I know about the relationship between the short side, the medium side, and the hypotenuse of a 30, 60, 90? Well, it happens to be right here. If the hypotenuse was 1, what would the short side be? 1/2, because it's half the length of the hypotenuse. So if you know the short side is 1/2, you multiply it by the square root of 3. This side would be the square root of 3/2, right? So what's the sine of a 30-degree angle? 1/2/1, which is 1/2. What's the cosine of a 30-degree angle? Square root of 3/2/1, which is just square root of 3/2. What's the tangent of a 30-degree angle? 1/2 over square root of 3/2, which, if you multiply both of them by 2, it's 1 over square root of 3. Can't leave square root of 3 on the bottom. So it is square root of 3/3. The tangent of a 30-degree angle is square root of 3/3. What is the cosecant of a 30-degree angle? Two. What's the secant of a 30-degree angle? 2 over square root of 3. Can't leave square root of 3 on the bottom. So multiply top and bottom by square root of 3 over square root of 3. So you get 2 square root of 3/3. And the cotangent of a 30-degree angle, which is square root of 3/2 over 1/2. So if we multiply by 2 to get rid of the denominators, we get just square root of 3. Okay? Now, let's find 210 degree angle. Let's look at a 210 degree angle. If this is 210 degrees from here all the way over to here, inside this, and I should redraw this just slightly. If it's 210 from here all the way over to here, what's this little angle in here? 30. And if this is 90, this is 60, and hey, a 210 is just like this one over here, right? So the 1/2 would go here, the square root of 3 over 2 would go here, and the 1 would go here, and this is negative and negative, right? Okay. So the sine of a 210 degree angle would be negative 1/2, because negative 1/2 over 1, right? Cosine of a 210 degree angle would be negative square root of 3 over 2. Tangent of a 210 degree angle would be square root of 3 over 3, and so on. Okay? You picking up what I'm putting down? So, if you have an angle like 30 degrees or 45 degrees, those are main angles, okay? Such as, let's look at a 45 degree angle. A 45 degree angle makes a 45, 45, 90 triangle, right? So if this is 1 and 1, then this is square root of 2, right? Okay. But in the world of trig, we like to have our hypotenuse as 1. So to get from the hypotenuse to the side, you divide by the square root of 2. What's 1 divided by the square root of 2? Well, you can't leave the square root of 2 on the bottom. So you multiply top and bottom by square root of 2, and you get square root of 2 over 2. Okay. So then, for the sine of a 45 degree angle, we get square root of 2 over 2 over 1, which is square root of 2 over 2. That's why we make the radius 1, to make life a lot easier. Now, to make life even easier, it would be so nice if we had something where we had every single value like 30, 45, 60, 120, 135, 150, 210, 225, 240, that, and that. 300, 315, and 330. If there was only something which had a radius of 1 unit that we could use. Only something which would be called like a unit circle that we could use as a cheat sheet. If there was only ever such something like that invented. Oh, there is something invented like that. And it's called the unit circle. Now, everybody gets a unit circle. You are not allowed to write on the unit circle besides your name. This is your calculator, you could say. Or your cheat sheet, you could say. But we don't like to talk about cheating in math. But the unit circle will help you out, and I'll show you how to read the unit circle. All right. Now, boom, file, print to OneNote, boom, print. I don't want 20 copies, but hopefully, it's going to do 20 copies. I'm going to have 20 unit circles all in a row. Yep, 20 unit circles. Oh, well. That's all right. All right, here's the unit circle as what you see in front of you. Now, remember we just had that 30-degree angle that we were playing with. Here's that triangle where we said this was square root of 3 over 2. This was 1/2. Okay? So, instead of having a triangle drawn there and all kinds of extra lines, what they do is they put the ordered pair here. Now, x is always the bottom of the triangle. Y is always the height of the triangle. Well, if you notice, if our angle's over here, our adjacent side is always going to be cosine, and our opposite side is always going to be sine. So what happens is your x is always your cosine, and your y is always going to be your sine. Now, you can't write on this. Okay, this is something you have to know, that you're going to have to memorize. That x, the x value of your unit circle is going to be your cosine. Your y value is going to be your sine. So y over x will be called your what? Tangent. What would x over y be called? Cotangent. Cotangent. Are you all right, Shanty? Yeah. All right. So, if I ask you, well, what is the cosine of 30 degrees? Well, it's sitting right in front of your face. 30 degrees cosine is sitting right there, square root of 3 over 2. It tells you the answer just by looking at it. If I asked you for the sine of 150 degrees, you look at 150 degrees, which is right here. You look at the sine, which is the y value, you get 1/2. If I asked you for the cosine of 270 degrees, well, 270 degrees is right here. The cosine is the first number. That is 0. Okay? Pretty easy. Now, what if I asked you for the tangent of 90 degrees? Tangent is what over what? Y over x. What's 1 divided by 0? Undefined. I'm glad you didn't say 0, or I would have had a mean Bierschbach on a tirade ram. Yeah. It would have been ugly in here because you can never divide by 0. Okay? Don't try to divide by 0. What's the cotangent of 90 degrees? 0 over 1, which is 0. What is the tangent of 7 pi over 4? Well, instead of looking at the degrees, you got to look at the radians. 7 pi over 4. You get this, which is negative square root of 2 over 2 over square root of 2 over 2. When you have the same things on top and bottom, what does that equal to? In this case, it'd be negative 1. Same things on top and bottom are 1, but they have opposite signs here. Okay? Where the only difficult part is when you're having to work with square roots. Okay? So let's say I have the secant of pi over 4. What does that equal to? Well, the secant is the reciprocal of what function? Cosine. So you take the cosine at pi over 4, which is 2 over the square root of 2, and that's your answer, but you can't leave the square root of 2 in the denominator. So you have to multiply top and bottom by square root of 2. So it's 2 square root of 2 over 2. And the 2's cancel to be just plain and simple square root of 2. Okay, so you got a little math, a little radical simplifications to do. The tangent of 7 pi over 6. Tangent of 7 pi over 6 is what over what, Chanty? No. Tangent is always y over x. Negative 1/2 over negative square root of 3 over 2. All right, this is a complex fraction. To get rid of complex fractions, we multiply by the denominator or the denominator. What's the denominator of the denominator? 2. So we multiply by 2 here and by 2 here. Then we get negative 1 over, the 2's cancel here, negative square root of 3. Negative divided by negative is a positive. And you can't leave square root of 3 on the bottom, so we multiply top and bottom by square root of 3. So you get square root of 3 over 3. Okay? Do you know how to read your unit circle? Can you handle that? All right, one last problem. Let's say we have the cosecant of 5 pi over 3. The cosecant of 5 pi over 3. Okay? What would we do there? Well, it's a reciprocal of which one? The sine of 5 pi over 3. What's the sine of 5 pi over 3? Negative square root of 3 over 2. So it's 2 over negative square root of 3. Can't leave square root of 3 on the bottom. Multiply top and bottom by square root of 3. So it's negative 2 square root of 3 all over 3. Okay? So, at the start of the assignment, you'll do a couple problems like what you had yesterday, where you have ordered pairs, you have to draw a triangle, figure out the hypotenuse, and figure out the 6 trig functions. Then after that, you're going to keep your unit circle out and work with the unit circle and figuring out values of sine, cosines, tangents, and so on. Some of the problems might involve getting out your calculator to figure out sines and cosines because it might be decimal numbers. So there you go. So get to work on it. It'll be fine. You'll make it through.